my final project, which is Pubmed article chatbot, Duan Lin. First, I will talk about the description, then I will show you the demo, then I will go to the architecture diagram, components, and implementations, and finally I will show you my performance result. So the Chatbot GUI is designed by BotUI, a JavaScript framework which makes it easy to build conversational UIs. And the chatbot should be able to handle plain language queries and answers. Basically, it supports two types of query. One is query by the terms in particular year. Another is range query in the scope of years. So for example, you can input search cancer in 2020 or search COVID-19 from 2019 to 2020. And it contains four approaches to search three different sizes of files. So there are Lucene, brute search, MongoDB, and MySQL as the database search. So here I choose three different size files, which contains like 4,000 papers, 15,000 papers, and also 30,000 papers as small, medium, large files. And it's able to display the searching history and track every user's questions and system's response results. And in order to better report the performance, which is the execution time of these approaches, I implement a visualize button that provides charts in the Chatbot GUI. And also these charts can be stored in the local folder, as I can show you later. So this is the UI preview, and I will show you my code and how to run it. So this is my Java code, and I use the Spring Boot to run my application. So now you can see I run my application now. And the application is running. So because I have already initialized my SQL tables and MongoDB's parse functions and all of the initialized work before I do the project, so I can just use the chatbot now. So this is the chatbot. So because we need to do the research on these execution time, so I will follow the workflows of the chatbots. So if I just click the small, and it will tell me that the Pubmed file selected, and I need to choose one of my searching approaches. So if I choose the MongoDB, and it will tell you that I need to follow the rules. I need to type like the search cancer in 2020, and I hit enter. So the result of the MongoDB will be displayed. And also you can check and search for the same content using the MySQL, like search cancer in 2020. And you can see the same result as we search the same content. So here you can view your search history, and I added the search history here. It will tell you your questions, your answer, and the response time. So now I will continue search the rest of the test. So this is the Lucene search. The Lucene search will cost a little bit more longer time, and you can see here. And also I can use brute search. So now you can see all of the result here. So we need to better do something about the medium file search. So as the same process, I will search like the range query here. So if I type the search cancer from 2018 to 2020, and it will tell you that the articles account from that range of years with the words is like 712 papers. And I will definitely continue my search. I'll a little bit go over faster because I have already shown you the the rules. Okay, the results will display here. It's from this is for Lucene result, and we have to do the brute force search. Okay, so we finished the small size and medium size query here, and you can check your history as we did before. So for the last part, I will show you the large file search. The first would be the MongoDB. So if I just like search COVID-19, like from 2019 to 2020, and it will tell you that there are like 1,844 papers during that time, and the response time is pretty quicker, so you can compare. And I will use MySQL to search COVID-19. The same result. The response time is pretty similar. And also for Lucene search, that would take a little bit more time on Lucene query. Yeah, and then the results, and also here. And finally, we have brute force search. And we will wait the result. Yeah, so here I did 12 experiments to do all of the search process here. So now I can see the plots. So if you click the show me the plots, you can see two different picture here. And because for brute force search and Lucene search, I will refresh the plots every time. So the reasons that you can see the large files and search the COVID-19 results here as the latest graph I created. But the MongoDB and MySQL query performance will tell you that there are 3 different sizes of files and their performance times with these little points. So that's the whole chatbot work. So I will back to, yes, I can show you the IntelliJ. And as you can see, the graphs can be generated here. So for this one is brute force search and Lucene compare when the file is small. And this is a medium situation, and this is the large situation. And it seems that the Lucene search may take more time than brute force search. And for themselves, they can have the unique different graphs here. So I plot a lot of graphs. Every time you can trace it and see what's going on. And I will back to my slides. So for my Chatbot architecture, I use Spring Boot to run application, and I implement the web service as the MVC framework and set routes to handle different queries in request controller, and the Chatbot search util class provides all search methods and initializers. So first, the users will input a query and get result from the chatbots. And as the backend framework, the Spring Boot provides the controller to get requests from the JavaScript. Like here, I use the BotUI to send a different URL request to our backend. So based on these different requests, the backend will go to the chatbot search utilize class, and this class, which contains all of the search methods, the parse XML methods, the database methods, the searching methods, all of that I completed in my previous homework. So basically contains a lot of methods to support the query function. And also it connects to the database. Here you have the MySQL database and my MongoDB database. And this is how it works in general. So for the detailed components, I have several components here. So my project's structure has different parts. So in the controller parts, basically handle all of the web request. You can read the parameters from the URL and pass these parameters to the chatbot search utilize class. And I implement all of the detailed things in that course in this class. If you want to check it, you just view my GitHub account, and I have already pushed my code to there. So for the front end, I just use a really simple HTML here, but I have implemented a lot of functions in the JavaScript file, as I need to add the message box and pop up the dialog window. Here the bot UI is basically add multiple message boxes and prompts to tell you what you need to do in the next step. So in the database part, I have MySQL database store 3 different types of table corresponding to 3 different size of files. And also the same things for the MongoDB. You can see how many documents and also the collections here. So the last part, I will tell you my test results as I show you before, but I need to summarize about it. So I did 2 different pairs of comparison. The first pair is brute force search versus the Lucene search. So as you can see, if the file is small file or medium file, the brute force search may perform more better than Lucene. But if the files become large, the Lucene may perform more better because it costs less time than the brute force search. Yeah, so this plot is used to plot the chart using the XChart. And the MongoDB compares to the MySQL part. So when search the same content with 3 different sizes, the MySQL is better than MongoDB if the file is more or large size. And the MySQL looks more better, but the MongoDB may performs better if the file size is medium. So that's all we can read from this chart. And I make a summary tables to tell you different search methods and different execution time with different file size. And basically, it's a tendency that you need to spend a lot of time when you have more papers to read to search. So this is a really intuitive results we can show you. So this is all of my final projects, and my result is presented here, and I hope you can understand what I'm talking. So thank you for listening.